All right, so we are graphing sine and cosine today. There are lots of cool videos out there to show you how the graph is derived or how you can take a bunch of values and create the graph. I'm not going to spend a bunch of time doing that today, but I am going to talk about what the shape of the graph looks like. So if I'm graphing the sine of x, what I'm going to graph is what we consider to be one full period of the sine function. So the sine function oscillates up and down. As you go around the unit circle, you calculate values. It goes up, down, back up, like so. Its highest point and lowest point, this distance should be the same. And we call that its amplitude. So it goes up and down that same distance. And then when it's completed one full cycle here, we call that one full period of the function. So what you're going to do is you're going to have an equation. And from the equation, you're going to come up with the period of the function. And it's half period. And label your axis like so. So what you'll see here is 4 or 5, I should call them, what do we call critical points. So we start at the line. Student of mine came up with a little bit of a rhyme that might help you. Sine starts on the line. So we start on the line. The next mark on the x-axis is a maximum value. Back to the x-axis where we started as 0 of a function, down to a minimum value, and then back to a 0. So 0 max, 0 min, 0. Or start on the line, up, back to the middle, down, back to the middle. That's what it looks like. The cosine function is very similar. In fact, they are just transformations of one another. But the same idea. We go up to the whatever the amplitude is, down to the amplitude from this line, which in this case, it's the x-axis, but it could be what we call a midline. And I'll talk about that later. The fourth mark out here is our period, whatever that might be. And then we have our half period. So half of that number, a quarter, 3/4. And the cosine function starts at the top. So starts with a maximum value to the x-axis, so a 0, to a minimum, back to the x-axis 0, and then ending with a maximum value. So its function looks like this. You want to make sure when you graph one period or however many period that you end the cosine function headed back down like this. It doesn't go straight up. They oscillate between their maximum and their minimum value, whatever that might be. But it never heads off towards infinity or down towards infinity. So same idea. This is one full period of the cosine function. Think of it as one cycle. It's repeating itself. And then this here is what we call the amplitude. The distance from the center to the maximum or the center to the minimum. So what is the basic equation? I don't have enough colors today. I'm going to have to use these two twice. Okay, so these numbers A, B, C, D represent, or those letters represent numbers and specific parts of the function. So the amplitude here is the A value, A for amplitude. And again, graphically, that's the highest, the difference between the middle and the max, the middle and the min. B is what we call the frequency. That's the number of times you see this happen between 0 and 2 pi. Also, b is used to calculate the period. The period of a normal sine function, so if I'm graphing just the sine of x, this period is 2 pi. And then if I have a b value, I divide that 2 pi by whatever number b is. So 2 pi over b is how we calculate the period. Now c is what we call the phase shift, which is if the graph is being shifted left or right. We won't be graphing any left-right phase shifts, so you won't see that in the notes that I've written up. D is the vertical shift, so up, down. And we call D the midline. So the midline, the vertical shift value, acts as the x-axis when we graph something with a function with a vertical shift. So we'll look at that in just a second with an example. Okay, so we'll start by identifying our A amplitude. So A is our amplitude, it's 1/2. Notice there is no horizontal shift, phase shift. There's no vertical shift. So those two I'm not worried about. I'm only worried about the 1/2 and the 3. The 3 is our B value. And so we'll calculate our period 2 pi over B, which is 3. So I'm going to graph 2 full periods of this function. And the easiest way to graph 2 full periods of a function is to draw them to the right and to the left on the x-axis. So this 2 pi over 3 is going to go out here at my furthest mark. And then half of that would be pi over 3. Half of pi over 3 is pi over 6. And then a sixth, a sixth, a sixth. This would be 3 pi over 6, but that's the same as pi over 2. So think of those in terms of the fraction with ignoring the pi. 2/3, 1/3. Half of a third is a sixth, and then a sixth plus a sixth plus a sixth. Each of these is an equivalent measure. So a sixth plus a sixth plus a sixth is 3/6, 4/6, and so on. Okay, so then the left side is exactly the same, just with a negative. Okay, so now since we're graphing the cosine function, we're going to start at the maximum value, and that in this case, that's a 1/2. So right up here on the y-axis, I'm going to label this mark with a 1/2, and then I'm going to label this mark down here with a negative 1/2. So I've labeled the 1/2 as my maximum value and minimum value, and I've labeled the 2 pi over 3 out here on the 1, 2, 3, 4th mark out. And so just like we talked about a second ago, the cosine function is going to start with them at the top. Cos starts at the top, kind of rhymes, but not really. And I don't like it being called cos because that's not correct. But so the second mark, or the first mark right here, will be at the x-axis, so 0. And then at the minimum, back to the x-axis, and then finishing back at a maximum. So the left side is going to mirror that shape. As you do these more, the more you do them, the easier the graphing piece will get. And I find because I'm right-handed that if I draw from right to left, I can see where I'm going, and it's helpful. Drawing from left to right is really difficult for me, and I just generally don't do it. So this is what the graph of this function, 1/2 times the cosine of 3x would look like. That's 2 full periods, one here, one here. Okay, so same idea. I'm going to go ahead and draw this so we can get that going. And then I'll label it as I go. So the 2 is our amplitude, but not the negative, just the 2. So what does the negative do? The negative is going to reflect the graph. And so as I draw it, I'll need to keep that in mind. But here on the y-axis, the graph is going to go up to 2 and down to -2. That's not going to change. It's still going up to 2 and down to -2 as long as there's no vertical shift. So the 1/3, if you notice, this x is the same as x times 1/3 is our b value. So when I calculate the period, 2 pi divided by 1/3, 2 pi divided by 1/3 is the same as 2 pi times 3/1, or 6 pi. Sorry, that's kind of smashing into my definitions over here. So 6 pi is our period, and that goes out here on the 4th mark. 6 pi. And so then half of 6 pi is 3 pi. Half of 3 is 3 pi over 2, so 1.5. And then 3 halves, 9 halves goes there. And then the left side matches. Okay, and since we're graphing the sine function this time, the graph would start at the line, right? So at the origin. Then the first mark would be a maximum, a 0, a minimum, a 0. But this negative right here is reflecting across the x-axis. Which means that instead of it going up, middle, down, middle, it's going to go down, back to the x-axis, up, back to the x-axis. So, like that. So starting at the x-axis, we go to a minimum, a 0, a maximum, and then back to a 0 because of the negative in front. If you're describing the words, the 2 is causing the graph to have a vertical stretch by 2. And the 1/3, think of it as a normal sine function completes its period in 2 pi. This is completing its period in 6 pi. So the 1/3 is a horizontal stretch and then instead of saying by 1/3, because you don't stretch something and make it a third of the size, you use the reciprocal and it's a 3. So this 1/3 is causing a horizontal stretch by 3. So what was finishing in 2 pi is now finishing in 6 pi, 3 times bigger horizontal stretch. Okay, I'm going to erase all of this, but I'm going to leave that because we're going to add a vertical shift to this graph. So how do you graph a function if it has a plus, let's go with 3. How does this plus 3, it shifts the graph up 3, right? So when I draw my graph, very similar to the way we drew the graph just a minute ago, we still put our 6 pi out here and 3 pi right there. I'm not going to label all the others because we already done it, and it's going to take some time. I'll save some time by doing that. Okay, so now what we're going to do is we're going to draw our midline at 3. We're going to put in a dashed line at 3. That is called our midline. Now that is going to act like our x-axis. So we have an amplitude of 2 still. So we're going to go up 2 and down 2 from that midline. And our sine function starts on the line. So this is where the sine function would start on the midline. That first mark is a maximum, so up to 5. Ooh, sorry. We still have the negative, so it's a minimum. So down to 1, back to the midline, up 2, back to the midline. And then the same thing happens over here. Up 2, back to the midline, down 2, back to the midline. So it looks like this. So again, when you have an addition or subtraction back here, that's a shift up or down. You draw your midline on that number. So if this was a -3, we'd be drawing our midline down here at -3. And then again, it acts like the x-axis. So the graph will start on that line and then either go up or down for a sine function. In this case, down for a negative sine function. Okay, so in the last section, they're going to give you an example of a graph and ask you to come up with some information based on the graph. Okay, something like this. Ooh, that's not very pretty. You get the idea. Okay, the ones are drawn much nicer in your assignment. Okay, so this is what it looks like. Your job is to come up with the amplitude, the period, the domain, and the range. Okay, so the amplitude, like we talked about a little bit ago, is the distance between the midline and the top, or the midline and the bottom. In this case, it goes from the x-axis up to 0.25 and the x-axis down to 0.25. So 0.25 is our amplitude. The period is how long it takes to complete one full cycle. So before it starts to repeat itself. This part right here is where it's starting to repeat itself. So one full period would be this section right here. So our period is pi over 3. And then the domain, the graph is going to continue doing this oscillation in both directions, to infinity and negative infinity. So the domain is all real numbers. And the range is how far up and how far down the graph goes. The graph goes up to 0.25 and down to negative 0.25 inclusive. So it touches 0.25 and it touches negative 0.25. So you could say negative 0.25 to 0.25, or you could write it in inequality notation like so. Okay, same idea. What is the amplitude? What is the period? What is the domain and range? So the amplitude, again, will be the distance from the midline to the top or the midline to the bottom. In this case, it's going up to 3 and negative 3, so our amplitude is just 3. Now, you should see more than one full cycle in this picture. In fact, you should see 3 of them. You should see 1, 2, 3. There are 3 full periods graphed here. So one full period would be when it goes from the bottom to the top, back to the bottom, and then it starts to repeat itself on each side. So there's one right there, there's one right there, and then it's repeating itself. So 8 pi is our period. And then the domain is, again, all real numbers for the same reason. And the range should match your amplitude. So negative 3 to 3. In this case, because none of yours examples today will be shifted up or down at all. If they were, that would then these two would not necessarily match. Okay, that's everything. Let me know if you have questions.